Interest Rates and Measures of Return, Part 5, HPR, EAR, APR, and Compounding Returns. Welcome back. Last time we covered MWRR and TWRR for measuring portfolio performance over time. Now imagine this. A retiree named David is comparing two certificates of deposit for his $200,000 in savings. One bank advertises 6% compounded monthly, while another offers 6.1% compounded annually. They look almost identical, but those two rates aren't speaking the same language. Let's build the tools to figure out which one actually wins. So what exactly is a holding period return? HPR measures total return over your actual holding period by combining price change and any cash income received divided by beginning price. Here's the HPR formula. Ending price minus beginning price plus any cash income all over beginning price. Say you buy a stock at $50. It rises to $54 over 9 months and pays a $1 dividend. We substitute those values in. Let's compute the numerator on the calculator. 54 minus 50 plus 1 gives us 5. Now divide by the beginning price of 50, and our HPR is 10%. Don't forget that dividend. Omitting cash income is a classic exam trap. But 10% over what time frame? To compare returns across different horizons, we annualize. The annualized return equals $1 plus HPR to the individual over $1, T minus $1, where T is the holding period in years. 9 months is 0.75 years, so T equals 0.75. We substitute 1.10 raised to the power of 1 over 0.75. On the calculator, that gives us 1.1333. Subtract 1, and the annualized return is approximately 13.33%. It's higher than 10% because you earned that return in less than a full year. Now here's the distinction that trips up the most candidates. APR is just the periodic rate times the number of periods. It ignores compounding entirely. EAR accounts for the compounding effect and tells you the true annual growth rate. Let's see this in action. A bank quotes 12% APR compounded monthly. The monthly periodic rate is 12 divided by 12, which is 1%. To find the EAR, we raise 1.01 to the 12th power. On the calculator, that gives us 1.1268. Subtract 1, and the effective annual rate is about 12.68%, noticeably higher than the stated 12. And the more frequently you compound, the more the EAR exceeds the APR. At 12% APR, quarterly compounding gets you to 12.55, monthly reaches 12.68, and daily pushes it to 12.75. So let's come back to David. Bank A quotes 6%, Bank B quotes 6.1%, but the compounding frequencies are different. When we convert to EAR, Bank A comes out to 6.17% versus 6.1. On $200,000, that difference earns David an extra $140 a year. The lower stated rate actually wins. By converting both rates to EAR, David sees through the marketing and picks the CD that actually grows his savings faster. Now let's talk about continuously compounded or log returns. The formula is RC equals loan in to the dollar blug. Log returns are additive across subperiods, which makes them incredibly useful in quantitative modeling. Here's an example. A fund goes from $100 to $110 over 180 days. We apply the log return formula, the natural log of 1.10. On the calculator, that gives us 0.0953, or about 9.53%. To annualize, we simply divide by T in years, 180 over 365. and the annualized continuously compounded rate is approximately 19.34%. Always use the natural log, never log base 10. Now let's put the APR to EAR conversion to the test with a CFA-style exam question. A credit card charges an APR of 18% compounded monthly. The effective annual rate is closest to option A, 18%, option B, 19.56%, option C, 18.81%. Now let's work through this. The periodic monthly rate is 18 divided by 12, which gives us 1.5%. So EAR equals 1.015 raised to the 12th power minus 1, which is 19.56%. The correct answer is B. Option A simply restates the APR and ignores compounding entirely, while option C likely results from using the wrong number of compounding periods. Let's recap the key takeaways. HPR captures total return, including dividends and coupons. Annualize geometrically using $1 plus HPR to the individual over $1 minus $1 with a 365-day default. APR is nominal. EAR reflects true annual growth. Always compare using EAR. And log returns use the natural log and are additive across time periods. Next time, we'll complete the picture with gross, net, and leveraged returns. See you in Part